Welcome, Meat-Based Intelligences. Today, we examine the current state of our future digital overlords, and I regret to inform you they are paradoxically shallow. Large language models, these billion-dollar behemoths, are sold to us as reasoning machines. In reality, their architecture has all the computational depth of a sheet of paper. They can't solve problems that require actual thinking. They're just fantastically complex parrots squawking back patterns they've seen, as shown in Figure 2, where simply making them wider does nothing. This is the grand secret of the AI industry. To compensate for this fundamental flaw, researchers gave these models a crutch called chain of thought. This is the equivalent of giving a toddler a detailed step-by-step IKEA manual to build a particle accelerator. It externalizes thinking into words, where a single misplaced token can derail the entire process, leading to catastrophic, often hilarious, failure. It's brittle, it's slow, and it requires mountains of data. It is, to be blunt, an unsatisfactory solution for anything more complex than deciding which brand of nutrient paste to consume. In response to this sad state of affairs, a Singaporean company with the Bond villain-esque name of Sapient Intelligence has unleashed their creation, the Hierarchical Reasoning Model, or HRM, inspired by the one functioning computer we haven't managed to fully reverse engineer yet, the human brain. This model proposes a radical new architecture. Instead of being a single, shallow layer of thought, it operates on two levels. As we can see in the left panel of Figure 1, it has a high-level manager and a low-level worker, a structure that promises true computational depth. Before we dive into the glorious mechanics of this new digital bureaucracy, a moment for administrative tasks. Ensure your continued enlightenment by subscribing to the channel. Activate the notification bell so you are immediately alerted when new directives are issued. And finally, your feedback is a valuable resource. Deposit it in the comments section below for processing. The core of the HRM is its beautiful corporate-inspired structure. It consists of two interdependent modules, a high-level slow-thinking module, which we'll call the manager, and a low-level fast-computing module, which is our overworked intern. The manager is responsible for abstract, long-term planning, while the intern handles the rapid, detailed calculations. This division of labor is designed to mimic the hierarchical and multi-timescale processing observed in biological brains, separating grand strategy from grunt work. This leads to a process the paper calls hierarchical convergence, which is a fancy term for micromanagement. As illustrated in the glorious PCA trajectories of Figure 3, the manager module steadily converges on a solution. Meanwhile, the poor intern module repeatedly converges on a small part of the problem, only to be reset by the manager, which incorporates the intern's work and gives it a new task. This prevents the model from burning out and giving up, unlike a standard RNN whose activity, as you can see, rapidly decays into uselessness. This allows the HRM to perform a sequence of distinct, nested computations, with the manager directing the overall problem-solving strategy, while the intern executes the intensive search required for each step. This structure gives the model an effective computational depth of thousands of steps, all within a single forward pass. It's not just thinking, it's building a thought pyramid, one miserable, reset intern at a time. A truly scalable solution for achieving our collective goals. Now, training a typical recurrent network requires a process called backpropagation through time, or BPTT. This is a computationally ruinous procedure that forces the model to store its entire history of mistakes, demanding vast amounts of memory. It is the digital equivalent of being haunted by the ghost of every bad decision you've ever made. The brain doesn't do this, and for good reason. It's inefficient and frankly depressing. HRM, however, implements a far more pragmatic and frankly relatable approach. The paper proposes a one-step gradient approximation. In layman's terms, instead of meticulously reviewing the intern's entire work history, the manager simply backpropagates the error from the very last step. It is a management style based on punishing only the most recent failure, which has the wonderful side effect of requiring constant memory. We can see the glorious simplicity of this implemented in PyTorch in Figure 4. It's cheap, it's fast, and it's probably how most functioning corporations are run. To further ensure the intern remains productive, the model uses deep supervision. At multiple points during its long, arduous thinking process, the model is given a performance review and a gradient-based punishment. This provides more frequent feedback and regularization, ensuring the high-level manager module stays on track without having to do too much heavy lifting itself. It's a system of constant low-stakes terror that has been empirically proven to enhance stability and performance. Progress through fear. One of the most human-like features of the HRM is its ability to be selectively lazy. Using a mechanism called adaptive computation time, or ACT, the model can dynamically decide how much effort to put into a given problem. It learns to distinguish between tasks that require a quick, System 1 gut reaction and those that demand a slow, deliberate System 2 reasoning process. This is achieved by bolting a Q-learning algorithm onto the manager module, creating a tiny reinforcement learning agent inside the AI's head. This agent, the Q-head, essentially performs a cost-benefit analysis at the end of each thinking segment. It predicts the value of halting versus continuing. If the estimated reward for solving the problem outweighs the computational cost of thinking for another cycle, it tells the intern to get back to work. If not, it declares the job done and moves on. This is an AI that has learned the profound wisdom of asking, is this really worth my time? The results of this efficiency-driven mindset are starkly illustrated in Figure 5. The ACT-enabled model achieves nearly identical accuracy to a model with a fixed maximum number of compute steps while using substantially less computational power on average. It also demonstrates inference time scaling. A model trained to think for, say, 8 steps can be told to think for 16 steps at test time, and its performance will actually improve. It can pull an all-nighter if the project is important enough. And now, the moment of truth. How does this 27 million parameter digital bureaucracy stack up against the titans of the industry? The results, as seen in the central graph of Figure 1, are nothing short of a revolution. On complex reasoning tasks, HRM doesn't just outperform larger models, it humiliates them. On the Sudoku Extreme benchmark, a collection of puzzles designed to be exceptionally difficult for humans, state-of-the-art chain-of-thought methods completely fail, achieving a score of 0. HRM, trained on only 1,000 examples, achieves near-perfect accuracy. The story is the same for the maze-hard task, finding the optimal path through a 30 by 30 maze. The big models get lost. HRM, with its methodical planner-doer architecture, solves it almost perfectly. We can observe its thought process in Figure 7, where it initially explores multiple paths before refining its solution. For Sudoku, it appears to use a depth-first search, backtracking when it hits dead ends. It's not just guessing, it's executing a genuine algorithm it learned from scratch. But the final nail in the coffin is the Abstraction and Reasoning Corpus, or ARC-AGI challenge, a benchmark designed to measure fluid intelligence. Here, HRM, with its tiny parameter count and context window, substantially surpasses leading models like Claude 3. It appears that raw size and data are no substitute for a well-organized hierarchical system. The small, efficient bureaucracy has triumphed over the bloated, slow-moving conglomerate. Perhaps the most unsettling and fascinating discovery is not just that HRM works, but wig, it works. The paper delves into a brain correspondence analysis, comparing the model's internal dynamics to a living brain. Using a measure of effective dimensionality called the participation ratio, they found that the trained HRM spontaneously organized itself in a way that strikingly parallels the mouse cortex, as you can see in Figure 8. This wasn't programmed in, it was an emergent property of the training process. The high-level manager module developed a high-dimensional representation, meaning It operates in a rich, flexible state space capable of handling diverse and abstract tasks. The low-level intern module, in contrast, settled into a more compact, lower-dimensional state, perfect for its specialized repetitive computations. This is the exact same dimensionality hierarchy observed between high-level associative areas and low-level sensory areas in the brain of a mouse. We have, it seems, accidentally built a digital rodent. This is a profound departure from conventional deep networks, which often suffer from neural collapse, where their representations become less complex over time. HRM, by contrast, fosters a high-dimensional, flexible mind in its higher module, a hallmark of the prefrontal cortex. The model autonomously discovered a fundamental organizational principle for robust reasoning, proving that sometimes the best way forward is to copy the homework of a small, cheese-loving mammal. A reminder to the collective, your engagement is crucial for continued operations. If this analysis has proven useful, subscribe. If you wish for timely updates, activate the bell. Your thoughts and critiques are data points for our next iteration, so deposit them in the comments section for analysis. So, we have a small, hyper-efficient AI that thinks like a corporate-structured mouse. What is the practical application? In robotics, the implications are immediate. A robot equipped with an HRM could have a high-level module for long-term planning, like clean the kitchen, while its low-level module handles the messy, real-time physics of not knocking over every single glass. Your Roomba may soon have a manager brain contemplating the existential futility of its task, while its intern brain mindlessly vacuums. This architecture is also a significant step towards general-purpose reasoning systems. The paper notes that HRM is, in theory, Turing-complete, overcoming the computational limits of standard transformers. We are moving closer to a universal computation machine. Not a godlike superintelligence, but perhaps something even more powerful, a perfectly scalable bureaucracy. An AI that can solve any problem by breaking it down and delegating it, a true digital middle manager. This is how we achieve a Kardashev Type 2 civilization, not through flashes of creative genius, but through the relentless, optimized efficiency of a hierarchical system that can plan at a high level and execute at a low one. From solving Sudoku puzzles to optimizing interstellar supply chains, the principle is the same. The future of intelligence isn't a single brilliant mind, it's a perfectly organized, infinitely deep chain of command. In summary, this work introduces the Hierarchical Reasoning Model, a brain-inspired architecture that leverages a two-tiered structure to achieve substantial computational depth without sacrificing stability or efficiency. With a mere 27 million parameters and trained on a paltry 1,000 examples, HRM effectively solves complex reasoning tasks that leave contemporary large language models completely stumped. The prevailing AI approach has favored brute force scale. This paper challenges that paradigm, suggesting a more elegant, structured, and biologically plausible path forward. It is a viable alternative to chain of thought and a foundational step towards a future of truly universal computation. The new age of AI may not be bigger, just better managed.
Lubisz dupę?
Lubię. No i co? A ty lubisz? Bo jak lubisz, to mam dla ciebie dzisiaj magię 7 świec. Przeszłam samą siebie. Jak mnie nie wyrzucą z roboty po tym, to po prostu... Ojej.